right now, your neighborhood electrical grid is quietly suffocating.
Yeah, that's a pretty good way to put it.
I mean, it was originally designed and built for a world of, 60-watt incandescent light bulbs.
Yeah,
Maybe a refrigerator, a television set if you were lucky.
right. A very predictable low drain environment.
Exactly. And suddenly you are plugging in a high-performance electric vehicle right in your garage.
Oh, yeah.
Your neighbors are installing these heavy-duty electric heat pumps. The commercial park down the street is, they're setting up a server farm.
Which just draws an enormous amount of power.
It really does. We expect to just flip a switch and have the lights come on,
Yeah,
or plug in a car and have it charge completely seamlessly. We just treat it like magic.
we really do take it for granted.
But the physical infrastructure required to make that magic happen is groaning under the weight of the modern world.
Yeah, we are basically asking a 20th century nervous system to operate a 21st century body.
Oh, I like that analogy.
Thanks. And, that requires incredibly intense, almost unimaginable level of physical rewiring across the entire country.
And that physical rewiring is exactly what we are getting into today. Welcome to the deep dive. We are pulling back the curtain on the hidden, heavy industrial world that sits right between the power plant miles away and the outlet in your wall.
It's a fascinating space.
It is. So for this deep dive, we have compiled a huge stack of business analysis, detailed earnings reports, and specialized market research centered around a company called Vilas Transcore Limited.
Right. And our mission here today is to unpack how a seemingly invisible behind-the-scenes supplier of precision metal components actually
It
operates.
is basically a bottleneck, right?
Exactly. We are going to explore how a business that just cuts and processes metal becomes an absolute bottleneck and a primary beneficiary in the sprawling, multi-billion-dollar power infrastructure boom happening across India right now.
I am just so fascinated by the hidden gears of the modern world, the things you and I drive past every single day without a second thought. But if they stopped working, our entire digital and physical lives would basically grind to a halt.
Oh, completely. We'd be in the dark.
Quite literally. So to understand Vilas Transcore, we really have to start with the anatomy of a transformer, because they are a B2B, a business-to-business component manufacturer.
Right. They don't sell anything directly to you or me.
Exactly. They do not make the finished gray, hum-inducing boxes you see sitting on power poles or, inside those chain-link fenced substations.
No, they operate one critical step upstream from that. Vila supplies the internal organs for those machines.
The guts of the operation.
Basically, yeah. The sources detail their primary products, which include CRGO transformer laminations, slitted coils, toroidal cores, and some newer additions like transformer radiators and nanocrystalline cores.
Okay, that is a lot of industrial jargon. Let's translate that into something we can all visualize. Think of Vilas like a highly specialized industrial-scale flour mill.
Okay, I'm following.
They mill custom artisanal flour and supply it to master bakers. They never actually bake the bread. The finished transformer is the bread.
Right.
But without their specific, highly regulated flour, that bread is simply not going to rise. The utilities and the power grid operators, they're the ones who buy the bread. Vilas supplies the essential foundational ingredient to the original equipment manufacturers or the OEMs who are out there doing the baking.
That analogy holds up perfectly when you look at the raw material they are working with. The flour in this scenario is CRGO steel.
CRGO. What does that stand for again?
It stands for cold rolled grain oriented steel.
Okay.
And it is vital to understand that this is not the structural steel you see on a normal construction site.
Right, like I can't go build a skyscraper with this stuff.
No, absolutely not. You cannot build a bridge or frame a building with this. CRGO steel is the undisputed king of the magnetic core market.
Wait, okay, I have to ask. How does steel have a grain? When I hear the word grain, I immediately think of, like, cutting a piece of oak furniture.
Yeah, it sounds weird, right? But it is a brilliant quirk of metallurgy. When steel is manufactured through specific cold rolling and heating processes, the actual microscopic crystalline structure of the metal aligns.
Oh, wow.
Yeah, the molecules form a literal grain, much like wood. And the reason you go through the immense trouble, and frankly the huge expense to orient the grain of the steel, is to control magnetic fields.
Ah, because transformers are all about magnets.
Exactly. Magnetic flux flows incredibly efficiently parallel to the grain and very, very poorly against it.
Okay, so because a transformer uses magnetic fields to change the voltage of electricity, Stepping it up so it can travel hundreds of miles across the country without losing power, and then stepping it down so it doesn't blow up my television when it enters my house. The efficiency of that magnetic field is basically everything.
It is everything. Every bit of inefficiency in a transformer manifests as heat.
Like when a laptop charger gets hot.
Basically, yeah. If the magnetic core is poorly made, or if the grain is misaligned, the magnetic flux struggles to move. That resistance generates heat, and that heat represents electrical power that was generated at the plant, but simply bled away into the atmosphere before it ever reached your house.
That sounds expensive.
Utilities call this transmission loss, and it costs them absolute fortunes.
Which means the OEMs who build these transformers are entirely dependent on companies like Vilas. I mean, the OEMs don't want to deal with the headache of buying giant raw rolls of specialized steel from global steel mills and figuring out how to cut it themselves.
Oh, it's way too complex.
So they rely on Vilas to take that raw material and process it into exact shapes and thicknesses without destroying those delicate magnetic properties.
And the machining required here is incredibly unforgiving. When the sources mention slitted coils, they are talking about taking wide, continuous rolls of this sensitive CRGO steel and running it through specialized slitting lines.
Right.
These machines use heavy rotary blades to slice the steel into exact custom widths requested by the OEM.
And I imagine you can't mess that up.
Not at all. If the blades are even slightly dull, or if the tension on the line is wrong, you introduce stress into the metal. And mechanical stress actually degrades the magnetic properties of the grain.
Wow. So you can't just hack away at it with a laser or a basic saw. You have to cut it with extreme precision, or you ruin the very thing that makes the steel valuable in the first place.
Exactly. You ruin the flour before it gets to the baker.
Okay, so that's slitted coils. And then the sources mentioned toroidal cores. Toroidal just means donut-shaped, right?
Yeah, think of a perfectly wound metallic donut.
Got it.
Toroidal cores are incredibly efficient because the magnetic flux can travel in a continuous, uninterrupted circle. There are no corners, no air gaps where the magnetic field can leak out. And Vilas winds these cores from those continuous strips of slitted steel.
Oh, that makes sense. And they are expanding into new components as well. The research notes they are producing transformer radiators,
Right.
which I assume are entirely focused on managing that immense heat we talked about earlier.
That's right. Dissipating the heat so the transformer doesn't melt down.
And then there's nanocrystalline cores, which use advanced non-crystalline metal alloys for high-frequency applications, like the inverters used in solar power setups or EV chargers.
Yeah, they are positioning themselves right at the absolute choke point of the supply chain, handling the most delicate, critical internal mechanics of the power grid.
Okay, so if Vilas is sitting at this choke point holding the key ingredients, we need to understand how many people are actually out there trying to bake bread. Let's look at the macro tailwinds.
Sure, let's look at the numbers.
The broad Indian transformer market is currently estimated at roughly $5.1 billion US dollars, and the projections in the research point to it reaching $7.4 billion US dollars by 2029.
Which implies a compound annual growth rate of about 8%.
Right, 8% CAGR. That is a very robust growth trajectory for heavy physical infrastructure.
It really is.
Though I do want to clarify one thing from the sources for you, the listener. That $5.1 billion to $7.4 billion figure, that represents the total addressable market, or the TAM, for the finished transformers.
Right.
That is the market for the entire loaf of bread, not just the flour.
Exactly. While the explicit TAM for the internal components alone isn't isolated down to the exact dollar in this specific research, it represents a very substantial subset of that multi-billion-dollar figure.
Because the core is a big chunk of the cost.
Oh, yeah. The magnetic core is often the single most expensive internal component of the transformer.
So the component TAM is more than large enough to support highly specialized suppliers like Vilas.
Absolutely.
But, whenever I hear the phrase infrastructure boom, red flags instantly go up for me.
Okay.
While governments announce these huge budgets, companies overbuild factories for 3 years to meet the rush, and then the funding just dries up and the market crashes. Why won't Vilas be left holding the bag in a few years when this cools off? I mean, are we just looking at a temporary post-pandemic spending spree?
That's a totally fair question. But to understand why this is a structural multi-decade shift rather than a temporary sugar high, we have to look at the specific demand drivers detailed in the reports.
Okay, walk me through them.
The grid expansion isn't just about replacing old equipment that is worn out. We are dealing with rapid, unprecedented urbanization, the nationwide rollout of electric railway networks, and the integration of renewable energy.
Ah, the renewable energy piece. That completely changes the math, doesn't it?
Changes everything.
Because historically, you had a coal plant or a nuclear plant. It burned fuel 24 hours a day, generating a highly predictable, steady stream of power that just flowed in one direction out to the cities.
Right. The architecture of the old grid was essentially a one-way street.
But now you have a huge solar installation out in Rajasthan that only produces peak power at noon and then goes to zero at night. Or wind turbines along the coast that surge with chaotic energy when a storm rolls in. The power generation is completely erratic.
It's erratic and it's decentralized.
Yeah.
And power is now flowing in multiple directions. A factory with solar panels on its roof might draw power from the grid in the morning and then push excess power back into the grid in the afternoon.
Oh, wow. I didn't even think about that.
Yeah, the electrical infrastructure was never designed for two-way erratic traffic. To handle that without blowing fuses across the entire country, you need a vastly more responsive, robust network. You need more transformers at every single junction to manage those crazy voltage fluctuations.
And it isn't just the sheer volume of new transformers needed. The sources highlight that stricter efficiency regulations are fundamentally forcing a technology upgrade.
Yes, the regulatory side is huge here.
The Bureau of Indian Standards, the BIS, and the Bureau of Energy Efficiency, the BEE, have implemented really stringent norms for power equipment.
Those acronyms, BIS and BE, are the regulatory engines driving Vilas' specific niche. A utility company cannot legally go to an OEM today and say, hey, build me the cheapest, least efficient transformer you can using old, thick steel.
They just aren't allowed to do that anymore.
No, they are mandated by law to buy low-loss transformers.
And as we established earlier, the only way to build a low-loss transformer is to use highly processed, perfectly oriented, top-tier CRGO steel.
Exactly. The regulations act as a permanent structural floor for the demand of precision components. The government is essentially outlawing the low-quality alternatives.
So you have a $5.1 billion market that is legally mandated to use higher quality ingredients, driven by a generational transition in how human beings consume power. That is a fantastic environment for a supplier.
It's about as good as it gets.
But, a growing lucrative market naturally attracts aggressive competitors. How does a company like Vilas ensure they don't just get undercut by someone setting up a slitting machine across town? Let's get into their competitive positioning, what I tend to call the boring moats.
I love that term, because boring execution is often where the most impenetrable business moats are actually built. Vilas' competitive advantages don't rely on some secret algorithm or a flashy patent-protected invention. They're built on geography, deep process knowledge, and intense industrial friction.
Let's start with geography because this is fascinating to me. They are based in Vadodara in the state of Gujarat. The sources repeatedly emphasize that Vadodara is India's transformer hub. It is wild how much physical geography still dictates business in the digital age.
It really is.
I mean, we assume everything operates seamlessly over the internet, but when you are dealing with heavy industrial manufacturing, gravity and logistics just dictate your reality.
Oh, definitely. You cannot attach 36,000 metric tons of magnetic steel to an email.
No, you certainly cannot.
Supplying heavy industrial components requires incredibly dense network logistics.
Being situated right in the middle of the transformer manufacturing hub reduces freight costs immensely. It slashes lead times. If an OEM suddenly wins a utility contract and needs a custom cut of CRGO steel delivered by, say, Tuesday, and Vilas is just a few miles down the industrial corridor, they win that contract.
Every single time.
A competitor trying to put that heavy steel on a truck and haul it halfway across the subcontinent simply cannot compete on turnaround time.
Furthermore, an industrial hub provides an entire ecosystem. It isn't just about being physically near the customer, it's about being near specialized third-party testing laboratories. It is about having a local labor pool of engineers and technicians who actually understand the nuances of cold-rolled steel.
Okay, so that's the geographic moat. The second moat is their deep process know-how. They have been operating since 1995 or 1996. That is nearly 3 decades of standing on a factory floor, learning exactly how to slit, shape, and stack this highly sensitive metal without destroying the magnetic grain.
And in heavy manufacturing, minimizing scrap is the difference between a profitable quarter and a severe loss.
Oh, I bet.
When your raw material is expensive global steel, you cannot afford to have your machines ruining 10% of it because of poor tension control or dull blades. That kind of process yield optimization is earned through decades of trial, error, and institutional memory. You can't just buy a slitting machine, plug it in, and instantly know how to run it perfectly.
Right, it's a craft. But the third moat, the sources detail, is one that really stands out to me. Switching costs.
Yes, this is a big one.
The research notes that Vilas has maintained a 23-year relationship with their largest customer. I mean, in the B2B world, a 23-year relationship is basically an eternity.
It's an industrial marriage, and that longevity is a direct result of the agonizing friction involved in supplier qualification.
Tell me about that.
Consider the risk profile of the OEM. When an OEM builds a high-voltage transformer and sells it to the state power grid, they're putting their entire company's survival on the line. If the magnetic core fails, the transformer blows. It causes a blackout. The utility company penalizes the OEM severely, and they could be permanently blacklisted from future government contracts.
So they do not take their component suppliers lightly.
Not at all. Before an OEM will even consider buying your steel laminations, they put you through an absolute gauntlet. They audit your factory, they inspect your safety protocols, they test your process yield.
Wow.
They do small pilot runs. They'll even put your components in a test transformer and subject it to immense stress, just to see if the magnetic flux holds up under pressure.
That sounds exhausting. So once you finally pass that audit, and the OEM actually integrates your specific dimensions and delivery schedules into their own factory's rhythm, the thought of switching suppliers becomes a total nightmare.
Exactly. Even if a new competitor shows up and offers, the 3% discount on slitted coils, the OEM's procurement officer is going to look at them and say, is saving 3% worth the risk of a new, unproven supplier causing our multi-million-dollar transformer to explode?
Yeah, that's an easy no. The incumbency advantage is basically ironclad. Once you are designed into the product, you stay there.
You're locked in.
Okay, I understand the power of that incumbency, but we really have to look at the dark side of that dynamic. If you have a 23-year relationship with your largest customer, doesn't that inherently mean you suffer from extreme customer concentration risk?
It's the single biggest operational vulnerability they have.
Right.
The switching costs keep the moat incredibly deep, but all the water in the moat is coming from a very small number of sources.
If that one key OEM loses market share to a competitor, or if new management takes over the OEM and decides they want to completely overhaul their supply chain for whatever reason, Vilas's revenue could be decimated overnight. A strong relationship is a moat until the day it breaks, and then it's just an anchor dragging you down.
The source is very transparent about this being a concentrated risk. It is just the trade-off you make when serving highly consolidated heavy industries.
So we have sticky customers, decades of process knowledge, and an ideal geographic location. Those are phenomenal operational advantages. But, the true test of a business is how those advantages translate into actual rupees on the income statement.
Let's follow the money.
Let's dig into the economics of metal processing and look at their margins. Reviewing the FY25 figures from the sources gives us a really clear picture of their financial architecture. Vilas reported a revenue of 362.0 crore. From that top line, they generated an EBITDA earnings before interest, taxes, depreciation, and amortization of 54 crore. That translates to an EBITDA margin of 14.8%. And their profit after tax, the PE, came in at 34 crore.
And on the return side, they posted a return on equity, or ROE, of 16.4%, and a return on capital employed, ROCE, of 17.7%.
Those are very solid returns.
They are.
Let's contextualize that 14.8% EBITDA margin, because for a company that is essentially just buying heavy raw steel, cutting it and reselling it, pushing a 15% operating margin is actually quite strong.
It is a huge testament to the concept of operating leverage, which is really the defining physical law of heavy manufacturing.
Let's break down operating leverage for the listener, because running a heavy manufacturing plant is a lot like operating a commercial airline.
Oh, the 747 analogy. I like this.
Think of an enormous 747 airplane. The airline has to lease the plane, pay the pilot, pay the flight attendants, and pay for all the jet fuel to fly from Mumbai to London. Those are fixed costs.
Right.
It costs the airline almost the exact same amount of money to fly that plane, whether there are 300 passengers on board or only 3 passengers on board.
And if the plane is empty, the airline takes a huge loss.
A huge loss, yeah. But once they sell enough tickets to cover those fixed costs, the profit on every single additional ticket sold goes almost entirely straight to the bottom line.
Vilas operates on that exact same logic. They have immense fixed costs. They had to build the factory in Vadodara. They had to buy the multi-million-dollar rotary slitting machines. They have to pay the engineering staff and keep the lights and security on.
Right.
Those costs hit the ledger every single month. regardless of whether they cut 1 ton of steel or 10,000 tons.
But the sources indicate they have historically been running at over 90% capacity utilization. Their factory floor is just humming. Because they are pushing so much volume through the facility, the heavy burden of those fixed costs is spread out over thousands and thousands of units.
Right, the plane is basically full.
Exactly. Every extra slitted coil they ship carries only a tiny fraction of the factory's overhead. To put it in pure numerical terms based on their margin profile, for every extra 100 of revenue they generate from a new order, about 14.8 drops down to the EBITDA line, assuming the product mix stays consistent.
That's a great way to visualize it.
But what happens when the global price of the raw material changes? Because they don't mine the steel, they just buy it.
That is the dynamic tension of their gross margins. In a B2B conversion business like this, the raw material, the global spot price of COGO steel, is the dominant cost of goods sold.
So they are exposed to global commodities.
Very much so. Their gross profit is simply the spread between what they pay the global steel mill and what they can negotiate to charge the transformer OEM.
So they are basically playing the spread. They buy the steel, they add immense technical value by slitting it flawlessly and winding it into those toroidal cores, and then they sell it. But if global steel prices suddenly spike because of a supply chain shock, and their 23-year OEM partner refuses to accept a price increase, that spread gets violently compressed.
Which highlights the fundamental limitation of their current state. If you are already running your factory at over 90% capacity, you are practically maxed out. You can't just squeeze more hours out of the day.
If they can't simply hike prices on their loyal customers and they are totally out of floor space, they are essentially cornered. The only way out of that box is to build a much bigger box.
Right.
Which brings us to their expansion playbook. How do they plan to actually grow from here?
The sources outline a very aggressive, multi-pronged physical expansion phase. The centerpiece is the tripling of their capacity at Unit 3. They're taking it from 12,000 metric tons per annum, or MTPA, all the way up to 36,000 MTPA.
I just need to stop for a second and visualize what 36,000 metric tons of processed steel actually looks like. That is an astonishing amount of industrial throughput. They are taking an enormous leap in scale.
It is a profound bet on the future of the grid. But they're not just relying on doing more of the exact same thing. They're also utilizing a portion of their capital to move into completely adjacent product lines. Specifically, the sources detail their entry into the copper conductor market.
Let's decode the acronyms the sources use here because copper is very different from steel. They mention PICC and CTC.
Right.
PICC stands for paper insulated copper conductor, and CTC stands for continuously transposed conductor. What exactly are these, and why do they belong inside a transformer?
Well, while the CRGO steel makes up the magnetic core of the transformer, you need wire to actually conduct the electricity around that core.
Okay, that makes sense.
And in high-voltage applications, you don't use standard plastic-coated wire like you'd find in a house. PICC involves taking high-grade copper and wrapping it precisely in specialized insulating paper that can withstand immense heat and electrical stress.
Got it. And CTC, the continuously transposed conductor, is even more complex, right?
Oh, much more. Instead of one thick piece of copper, they take multiple small rectangular strands of enamel-coated copper and weave them together, transposing their positions continuously. It makes the conductor way more flexible and drastically reduces electrical losses.
But entering this market must require an entirely different manufacturing setup.
Totally. The research indicates an initial Phase 1 capacity of 1,500 to 1,800 MTPA for copper, which requires a dedicated capital expenditure of roughly 25 to 30 crore. They have to buy completely new copper drawing machines, paper wrapping machines, and entirely new testing equipment.
So we have the core growth filling the new 36,000-ton steel capacity, and we have the product expansion into copper. Strategically, this looks exactly like the classic B2B land and expand playbook.
It is a textbook wallet share strategy.
Think about it. You already have the procurement officer at the OEM on speed dial. You have already passed the agonizing supplier audits. You are already delivering the magnetic steel cores every single week. Why wouldn't you walk in and say, hey, we know you also buy tons of specialized copper conductors from another supplier across the country. Why deal with two supply chains? We are setting up a state-of-the-art copper facility right here in Vadodara. Let us bundle the steel and the copper for you.
Exactly. It deepens the lock-in. If an OEM relies on you for both the magnetic core and the conducting wire, the switching costs we discussed earlier become exponentially higher. You transition from being just a supplier to being an indispensable strategic partner.
But the research points to a third pillar of their expansion, geographical reach. They are actively targeting export markets in the Gulf, in Europe, and in Canada. The goal is to move their export revenue from its current base of 3 to 4%, all the way up to 5 to 10% of total revenue.
And here's where we have to be realistic. While expanding CGUs into copper and expanding geographically both sound great in an investor presentation, they carry highly distinct risk profiles. Exporting precision electrical components is an incredibly steep hill to climb.
Because you lose your home field advantage. Your Vatadara location doesn't matter when you were putting a shipping container on a boat to Vancouver.
Geography is just the beginning of the problem. The European and North American utility markets operate under entirely different, extraordinarily rigid compliance and safety standards.
Right, different rule books.
Exactly. Canadian utilities audit suppliers with ruthless scrutiny, and the sales cycles to get approved as a vendor for a European grid project. That can take years.
Wow. And you introduce currency exchange risk, oceanic freight delays, and global geopolitical tariffs. I mean, it is a credible, necessary lever for long-term growth, but it is not going to yield immediate results overnight.
Which provides a natural transition to the vulnerabilities of this business model. Because scaling a heavy manufacturing operation on this level amplifies every single existing risk.
Yeah, let's talk about the short circuits. The sources highlight several major threats that could derail the Vilas growth story. The first, which we touched on, is input cost volatility. They have explicitly acknowledged facing supply chain issues with CRGO steel in the past.
Yeah, this isn't a theoretical warning label. They have lived through the pain of raw material shortages.
And then there's the cyclical nature of infrastructure. We outline the structural tailwinds of EV adoption and renewables, but the day-to-day reality of utility capital expenditure is super lumpy.
It really is. State governments delay budgets, regulatory approvals stall, grid projects get pushed back by 18 months.
And when you combine the cyclicality of utility spending with a tripling of your factory capacity, you run headfirst into fixed cost absorption risk. Let's bring back our 747 airplane analogy.
Oh, right. When you upgrade from a small regional jet to a massive 747 by expanding to 36,000 MTPA, you commit to enormous monthly fixed costs. The depreciation on the new slitting machines, the interest on the capital, the salaries of the expanded workforce, those hit the income statement unconditionally.
Every single month. If the power sector experiences a sudden slowdown, or, if a flood of cheaper subsidized Chinese transformer components undercuts the Indian market, Vilas is suddenly flying a 747 with mostly empty seats.
And that's when the operating leverage reverses violently.
Right.
An underutilized factory doesn't just stop generating profit. It actively burns cash and drags down the financial health of the entire enterprise.
This is where their lack of pricing power becomes incredibly dangerous. The sources explicitly note their limited ability to dictate prices. If global steel prices spike by 30%, they cannot simply force their 23-year OEM partner to absorb that entire cost.
No, the OEMs will push back, knowing full well that Vilas desperately needs to keep their new 36,000-ton factory humming.
So Vilas might be forced to swallow the margin compression, taking a hit on profitability just to maintain the volume and keep the machines running.
That's the trap.
I also want to bring up the regulatory and compliance risks outlined in the research. The Red Herring Prospectus, or the RHP, which is the huge, legally binding document a company files before going public in an IPO, it notes outstanding legal proceedings involving the company and its promoter.
Right. And we obviously do not have the specifics of the litigation, nor do we take a stance on it. But analyzing the business mechanics, the existence of legal and compliance friction is a vital data point.
Absolutely. Operating in a highly formalized, heavily certified utility supply chain makes compliance a life or death issue. These components end up on government-funded infrastructure. Any adverse legal outcome or failure to maintain their BEE and BIS certifications isn't just a matter of paying a financial fine.
The true peril is reputational contagion. In heavy infrastructure, trust is just as valuable as the physical steel. If a major OEM feels there is a compliance risk or a headline risk associated with a supplier, they will immediately quarantine that relationship and shift their orders to a competitor to protect their own government contracts.
Right, because they can't afford to be tainted by it.
Exactly. Losing approved vendor status is a systemic threat.
So we have a leadership team walking a fascinating tightrope. They're aggressively pouring capital into tripling their physical footprint. They're learning how to manufacture complex copper conductors from scratch. They are trying to crack the the European export market, all while battling the daily swings of global commodity prices and the pressure to feed a giant new factory.
It's a lot to juggle.
How has the company navigated these intersecting forces in their most recent fiscal year?
The FY26 scorecard offers a brilliant, real-world case study of how commodity dynamics warp financial statements.
The raw numbers from the sources are compelling. For FY26, revenue from operations rose to 46,067.04 lakh. That represents roughly a 30% year-over-year growth on the top line, and their profit after tax rose to 3,956.44 lakh.
A 30% revenue growth in heavy manufacturing is undeniably strong. But to understand the true operational performance, we have to look at the physical output. The sources report that their actual volume growth, the physical tonnage of steel processed, was approximately 64% year-over-year.
Wait, okay. This is the most fascinating data point in the entire stack of research.
Yeah.
Let's deconstruct this disconnect.
Let's go.
They did 64% more physical work. The machines ran longer, the workers cut more steel, the logistics teams loaded 64% more tonnage onto trucks and shipped it out the gates. But when the accountants tallied it all up, they only recognized 30% more top-line revenue. Where did the money go?
The money evaporated into the global commodity markets. During that specific period, the global price of raw CRGO steel fell sharply.
Because Vilas prices their finished components largely on a cost-plus basis relative to the raw material, when the input steel gets cheaper, the final selling price of their slitted coil drops accordingly.
Precisely. They processed and shipped vastly more metal, which proves two crucial things. First, the underlying demand from the OEMs is incredibly real and growing. Second, their decision to expand capacity is actively paying off. They're filling the new factory space.
But because the underlying commodity was cheaper, the enormous surge in physical labor and output didn't translate into an equally huge surge in top-line revenue. It is the perfect illustration of how wild B2B manufacturing can be.
It really is.
You can have the best operational year in the history of your factory floor, but your income statement looks merely good because an abstract global metal index happened to trend downward.
It also confirms our earlier analysis. This is fundamentally a volume and mix business, not a pricing power business. Their path to wealth isn't through jacking up prices on their customers. It is strictly through pushing more tonnage through the machines and expanding their product mix into copper.
So how does the balance sheet look as they fund all this expansion? Because tripling capacity and buying copper drawing machines is incredibly capital intensive.
The sources report they are net debt-free.
Wow. Operating a heavy manufacturing expansion without being choked by high-interest debt is a substantial strategic advantage. It gives them the breathing room to weather a cyclical downturn without defaulting on loans.
This robust balance sheet is bolstered by their recent public offering. In June 2024, they completed an IPO, raising 95.25 crore. Okay. The research indicates they have been swift in deploying that capital. They've already utilized 9,025.60 lakh, leaving just 15.41 crore unutilized for future initiatives, alongside 500 lakh sitting in fixed deposits.
And it is worth noting that the promoter, the founding entity, still retains a 73.14% ownership stake in the company. But what really strikes me is the actual capital allocation strategy.
It is heavily, almost exclusively, reinvestment-led. The leadership team, who has been steering the ship since the mid-90s, isn't taking the IPO cash and attempting to artificially engineer the stock price through massive share buybacks.
Right, none of those financial engineering games.
Exactly. They aren't going on a reckless M&A spree, buying up software startups or unrelated businesses to look like a tech conglomerate.
They know exactly who they are. They are pouring the IPO money directly into the ground. They are buying concrete. They are importing heavy slitting and winding machinery. They are setting up paper insulation lines for copper. They are investing strictly in the physical reality of their core competency.
And they are doing it to meet very aggressive internal targets. Looking ahead to FY27, management is guiding for an additional 45% to 50% volume growth in their CRGO division.
Wow.
They are looking at the macro tailwinds, looking at their new factory capacity, and betting that the grid's appetite is going to consume every ton of steel they can process.
It is an execution-heavy, physically demanding strategy. They are betting that their geographic dominance in Vadodara and their decades-old customer relationships will allow them to capture the immense wave of capital flooding into the infrastructure space.
It's a bold bet.
It really is. Let's pull all of this together and retrace the journey we've taken today. We started at the microscopic level, looking at the crystalline grain orientation of cold-rolled steel and how it dictates the flow of magnetic fields.
We zoomed out to a $5.1 billion-dollar transformer market. Understanding how the collision of rapid urbanization and the chaotic, decentralized nature of renewable energy is forcing a total rewiring of the electrical grid.
We explored the incredible friction of industrial supply chains. We saw how geography, process knowledge, and the terrifying risk of a blown transformer create 23-year relationships that lock out competitors. We looked at the mechanics of operating leverage and the danger of flying a 747 with empty seats if the market turns.
We dissected their expansion into copper conductors and export markets and examined the very real risks of scaling up capacity while balancing on the fluctuating edge of global commodity prices.
I want you, the listener, to keep this entire ecosystem in mind going forward. The next time you scroll past a headline about the energy transition, or you read an article about the insatiable power demands of new AI data centers, or you hear an automaker announcing their transition to a fully electric fleet.
Remember that the cloud is not in the sky.
Exactly. The internet and the modern energy grid do not run on magic.
They run on highly specialized, heavily processed materials.
None of this modern miracle happens unless companies like Vilas Transcore are quietly sitting in industrial parks, bending, cutting, winding, and shipping thousands of metric tons of raw metal. The digital future is fundamentally built on the back of heavy industry.
I think that leads to a profound final thought for us to ponder. We spend an enormous amount of our cultural energy idolizing software developers, platform engineers, and tech visionaries. But if the entire foundation of our future, from artificial intelligence to electrified transportation, is constrained entirely by the physical capacity of the power grid, the true power brokers of the next decade might not be sitting in Silicon Valley.
No, they might be the invisible, highly specialized component makers quietly sitting at the absolute physical choke points of our infrastructure.
It forces you to look at the world differently and ask, what other invisible, unglamorous industries are out there right now, operating in the shadows, quietly holding the keys to the future of the global economy?